All right, on page 568 today, we are going to be talking about trigonometry. Ratios. Trigonometry ratios. And we're going to say a trig ratio is a ratio of the lengths of two sides of a triangle as they relate to an angle. Trig ratio is a ratio of the lengths of two sides of a triangle as they relate to an angle. Now, the acronym for trigonometry ratios, this is the most important part of this section. There's an acronym, we pronounce it SOHCAHTOA. It's spelled SOHCAHTOA. SOHCAHTOA. It's an acronym to use as a reminder of which sides form each ratio. Here's what I mean. There's three trigonometry ratios you're going to be working with this week. One of them is sine. Another one is cosine. And the third one is tangent. The S in SO corresponds to the S in sine. And the sine of an angle is equal to its opposite side over the hypotenuse. That's where the S, the O, and the H come from in the acronym. Sine equals opposite over hypotenuse. In the middle of this acronym, the SOHCAH, C-A-H, the C corresponds to cosine. Cosine of an angle is equal to the adjacent side over the hypotenuse. All right, so cosine equals adjacent over hypotenuse. So cosine equals adjacent over hypotenuse. And then finally, TOA, the T corresponds to the T in tangent, equals the opposite side over the adjacent side. So TOA, the T for tangent, tangent equals the opposite side over the adjacent side. SOHCAHTOA, SOHCAHTOA, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Now, you're going to use these ratios this week to find side lengths in triangles. And then we're going to use the inverse function of these ratios to find angle measures in triangles. Okay? So let's get this triangle on your paper. And we're going to label it ABC. We're going to give it some side lengths today. We're going to give it an 8, a 15, and a 17. And we're going to write the sine, cosine, and tangent of angle A. And then we're going to write sine, cosine, and tangent of angle B. So in relation to angle A, this is our angle A right here, up top. In relation to angle A, sine. Oops. Sine just becomes SIN now. Sine of A is equal to opposite over hypotenuse. So opposite of angle A is 8. The hypotenuse of this triangle is 17. So our sine of angle A equals 8 over 17. Our cosine of A, and we abbreviate cosine with just cos. So cosine of A is equal to ca, the CAH, right? So cosine of A is the adjacent side, the side next to angle A, which is the 15, over the hypotenuse, which is 17. And then tangent of A, and we just abbreviate tangent with tan of A, is equal to tangent. That was the TOA. Tangent equals opposite side over adjacent side. So that's going to be opposite of A is 8, and adjacent to A is 15. And then we can take all of these ratios, we're rounding them to the nearest hundredth, so we can set our calculator to second fix 2. And then we're just going to take 8 divided by 17, which is 0.47. And then 15 divided by 17, which is 0.88. And then 8 divided by 15, 0.53. So there's your sine, cosine, and tangent of angle A as a ratio and as a decimal rounded to the nearest hundredth. So the next thing we're going to do is we're going to write the sine, cosine, and tangent for angle B. And here's our angle B. All right, so sine of B is equal to sine, that's the SOH, opposite of B over hypotenuse, so 15 over 17. Cosine of B, cosine is CAH, ca, so ca toa. The A represents the adjacent side to the angle over the hypotenuse, so we got 8 over 17. And tangent of B, and tangent is the TOA, opposite side over adjacent side. So opposite of B is 15, and adjacent to B is the 8. So a lot of times when you're working within the same triangle, you're going to have crossover ratios, meaning the sine of angle B is equal to the cosine of angle A. So we can use the same decimal version. We got 0.88. And cosine of B is the same as sine of A, so that's 0.47. And the tangent doesn't correlate, so we're just going to take 15 and divide it by 8, and we get 1.88. Everybody okay with that? Make sure you understand that once you're given this triangle, the hypotenuse is the hypotenuse. The hypotenuse is always the side opposite the 90-degree angle. You may want to label it when you draw the picture. Hypotenuse. What happens is some people in the past have confused the hypotenuse with the adjacent. All right? But once we label the hypotenuse, it can never be an adjacent angle. All right? Opposite of A is the side opposite of angle A. And then adjacent to A is the side that helps form A with the hypotenuse. All right, so be sure that you're real careful about that when you are writing these ratios. Sorry, so that's as far as we're going to go today with these ratios. We're just going to write them, and then we're going to put them into simplest form. And then tomorrow we're going to start using these ratios to find some side lengths and some angle measures. Yes? A little louder, please. I can't hear you. You're never going to find the sine, the cosine, or the tangent of the right angle. Okay? All of these ratios are designed to be used in right triangles. We're never going to use, or we're never going to write sine, cosine, tangent for angle C, because its opposite side is the hypotenuse, and its other two sides are both adjacent. So the rule doesn't work when you're looking at the right angle portion. All right, so your practice for today is going to be on page 573. We're going to do 1 through 6, and then 16 through 21 down on the bottom of the page there.